Good day. Our lesson today is on tangents from an external point. So given this circle and this external point here are the tangents to the circle from the external point. These are the tangents. We already know that the tangents are lines drawn from a point to the circle that touch the circle at one point. So this is tangent TA and TB. Therefore, they are equal. So TA is equal to TB since they are from the same external point. And we know that AO is a radius, BO is a radius. So AO is equal to BO since both are radii. So we can also say that TO like this, TO bisects this quadrilateral, so it also means that angle TAO is equal to angle TBO since they are both right angles. They are both 90-degree angle. Angle ATO is equal to angle BTO since OT bisects this quadrilateral. So these angles are equal. And also triangle ATO, that is the triangle, is equal to triangle BTO, It is now time for examples. Example 1, given that angle ATO is equal to 36 degrees, calculate angle ABO. Angle ATO, this is angle ATO 36 degrees. We can use this to calculate angle, this is x here, so to calculate angle TAX. Since this TAX is a triangle, this is 90 degrees because of symmetry. So angle TXA is equal to 90 degrees. So to calculate angle TAX is equal to 180 minus 90 degrees plus 36 degrees. Why? Because of angles in a triangle. So TAX is equal to 54 degrees. We now have angle TAX. This is 54 degrees. And because of the issue of symmetry, TAX is equal to TBX because of symmetry from what we said earlier on. So TBX is equal to 54 degrees. We now have TBX. This is 54 degrees. So now we want to calculate angle ABO. We know that angle TBO is equal to 90 degrees. Why? Because the radius is perpendicular to the tangent to a circle. So to calculate angle ABO plus angle TBX plus TBX is equal to 90 degrees since these are the two angles, this and this. So we know that angle ABO plus TBX is 54 degrees is equal to 90 degrees. So ABO is equal to 90 degrees minus 54 degrees. Therefore, ABO is equal to 36 degrees. So we have calculated angle ABO using the theorem that we have discussed earlier on. Now example 2. A, B, C are 3 points on a circle, center O. So we draw up our circle, center is O, and we have points A, B, and point C. Such that BAC is equal to 37 degrees. This is BAC is equal to 37 degrees like this. The tangents at B and C meet at T. So we have a tangent from B and a tangent from C. They meet at T. Calculate angle BTC. We want to calculate this angle. This is the angle that we are looking for. So the first thing that we have to do is we join BO like this. This is a radius and this is a radius. BO and CO, they are both radii, and we know that from what we did earlier on in our last video, we know that this angle BOC is twice angle BAC. That is, angle at center is twice the angle on the circumference. So BOC is equal to 2 times BAC because of angle at the center being twice the angle at the circumference. 2 times 37 degrees. So this is equal to 74 degrees. We now have this angle. This is 74 degrees. We also know that angle TBO is equal to angle TCO. Angle TCO, because they are both, the radius and the tangent are perpendicular. They are 90 degrees, the angles, and we can see that this is a quadrilateral. TBOC is a quadrilateral. The angles add up to 360 degrees. So the only missing angle is this angle. This is 90, this is 90. So to find angle BTC, angle BTC is equal to 360 degrees minus 90 degrees plus 90 degrees plus 74 degrees, because of angles in a quadrilateral. This is equal to 106 degrees. 106 degrees. So let's now proceed to the exercise. May you please carry out the exercise that is on the screen. Pause the video, carry out the exercise, and check out the solution thereafter. Now for the solution, we'll start with number 1. We are going to work it out here. The solution for number 1. Okay, so we are given angle BTO. This is 44 degrees, and we know that angle BTO is equal to angle ATO. So angle BTO is equal to angle ATO because of the issue of symmetry. So angle ATO is equal to 44 degrees. Here it is 44 degrees. And we know that angle TXA is 90 degrees because of symmetry. So TXA is equal to 90 degrees. It's equal to 90 degrees. And you want to calculate angle TAX. This is a triangle. We have two angles, so we can calculate angle TAX like this. TAX is equal to 180 degrees minus 90 degrees minus 44 degrees. Angles in a triangle. So this will be equal to 46 degrees. We have calculated angle TAX. Now let us proceed to number 2. For number 2, we are given that PQR are 3 points on a circle center O. So we have this circle center O with P, Q, and R are 3 points on a circle center O. The tangents at P and Q meet at T. This is point T. We have a tangent at P, and at Q they meet at T. These are straight lines. They are meeting at T. If PTQ is equal to 62 degrees like this, we want to calculate this angle PRQ. This is the missing angle. So the first thing that we do, we draw up a radius here, like this, and we can see that PTQO is a quadrilateral. It is a quadrilateral, and angles in a quadrilateral add up to 360 degrees. And we know that this angle is 90 degrees, this angle is 90 degrees. Why? Because it is the meeting point of the radius and the tangent because of the perpendicular thing. So we can say that angle, we are looking for angle POQ. Angle POQ is equal to 360 degrees minus these three angles that we already have, 90 plus 90 plus 62 degrees, like this. So this is equal to 118 degrees. So this is 118 degrees. Now we want to look for angle PRQ, and we know that angle at center is equal to 2 times angle at circumference, if they are in the same segment. So this means that angle POQ is equal to 2 times angle PRQ. Therefore, we have POQ is 118 degrees is equal to 2 times PRQ. If we divide both sides by 2, this one, then this will be 59. Therefore, PRQ is equal to 59 degrees. Okay, thank you for watching my video. May you please subscribe to my YouTube channel, Free Tutorials ZW, for more video tutorials.